G'day YouTube and welcome back to the ASX Portfolio channel. Today you are going to learn how to run simulations across your clusters. Now we're going to be using Python, we're going to be learning how to use Slurm scheduler. So we're going to be writing bash scripts to schedule different simulations running Python. So let's get into the video. For the first part here, you can see that I'm logged into my master node. Now I've got Garrett Mills' building a Raspberry Pi cluster tutorial. This is part 2. Now the first part that we're going to actually learn about is just the Slurm basics. So again, it's just a scheduler. So we're logged into our main node. If you remember, you can type sinfo to check the status of our cluster. We have 3 idle nodes, 0 to 01 to 03, and the partition is my cluster. Now, if we use srun nodes equal 3 host name, it's just going to return the host names of our 3 nodes. Now you'll notice if we use srun and tasks equals 3 host name, we can run a certain number of tasks on or across our clusters. If I do 4, it'll come from the same cluster. If I go over 4, then you'll notice that it distributes it across the nodes. Why does it do that? Because essentially on each node I have a quad processor. So I've got 4 cores per node, 4 threads. So I can only run 4 tasks at a time per node. Now, one of the things you can do, instead of just dictating the number of tasks or the number of nodes, you can actually run your scripts on a specific number of nodes. So let's say equals to 3, and then the number of tasks per node. Now remember, the number of tasks we just went over per node, dash dash, n tasks per node is equal to 4. Now that is the maximum. We can't run any more than that because of the 4 cores, 4 threads per node. You'll see if we go one more than that, we don't have the correct configuration. We're waiting for additional resources. So we can't run that. The same thing happens if you try to use more tasks and tasks equal to 5. This will be able to run, but if we go over 12, we will not be able to run it. Waiting for additional resources. So the way that you can see, you can actually view scheduled jobs is in this SQ. Now SQ, obviously I don't have anything running right now, but we will use this eventually. SQ can have this user command, so -u, and my user right now is Pi, but I could set up other users for the cluster and be able to view their progress here. To cancel a specific job, as you can see in the tutorial, it's just cancel, and then you can list the actual job schedule. You can also get rid of an entire users by specifying the user, and we could cancel all jobs on that user. So yeah, pretty handy. Slurm is a great batching scheduler. The bash file, what we need is a bash file that's actually going to be, well, a batch file that runs our jobs. Now this can be very, very different, but essentially all of these scripts start with the same header. We've got this ! bin bash, and then the sbatch parameters. So we classify the number of nodes, the number of tasks per node, the partition you can name. So our first project. So Garrett Mills uses R programming language, and he just simulates the normal distribution. He gets 100,000 samples and he plots that on a graph. Cool, he does that 50 times. What we're going to do, we're actually going to use a bit of code from my website, from geometric Brownian motion simulation. So we're just going to simulate geometric Brownian motion using different volatility, different time, and a different number of simulations. So we're going to use all those parameters there. So first thing I want you to do is go to my website and go to that specific tutorial, link in the description, and then we're going to hop into Visual Studio. So the first thing we're going to do in Visual Studio is create that Python file. So let's go. And what we're going to do, we're going to call that simulations.py. So all I want you to do is go to my website and copy down all the bits of code from geometric Brownian motion. Now, here we need to import numpy as MP. I think that's our only dependency. But for the use case of running on the cluster, we need to import sys, and we need to import time, or from time, we want to import process time. And this is so we can actually time how long our computation takes. It's always a nice thing to have. So now that we've imported the dependencies and we've got the bulk of our script, what we need to do is actually make a function so we can call it from bash, and we can call the arguments that we want. So let's define a function, and we're going to call this geometric Brownian motion underscore BM, and we're going to have the number of sims, I'll call that. We're going to have the volatility, and we're going to have the stock price. So replace those parameters. M was the number of sims, volatility was sigma, and the price was the initial stock price there. Now just tab that over so it all comes within the function. Save. And what we're going to do is we're actually going to print just all the stock paths that we have. So stock paths that we're simulating, space st. Perfect. So that's all our function's going to do. So to run this script, we're going to check whether this is the main script that's being used, and then if so, we're going to run some things. So if underscore name is equal to main, if this is the main script, then what I want to do is I want to collect some arguments. So I want to collect the sims. I want to collect these arguments up here. And actually I'll copy this function because we want to execute this in a second. So I want the sims, I want the volatility defined, and I want the price. Where am I going to get these things? Well, I'm going to take them from the arguments. Now this is stored in sys.arg, and this is going to be 1, sys.arg2, and this is sys.arg3. So I'm going to time how long it takes for this run. So what I have to do is go start equal to process time. That just records the system time right now. Then I'm going to print total time space, and what I'm going to do is take the process time at the end minus the start time. And that should work perfectly. And that's all we need for our main file. So this is our simulations file. So what I'm going to do, I'm going to copy all that and I'm going to put it on my main node cluster. So let's cd into cluster nano simulation.py. So I've created a Python file, I've just copied and pasted that into here. Do I want to modify it? Do I want to save it? Yes. So now I've got my simulation file list. Excellent. So now that we've got the Python script, what we actually need to do is we need to organize Python on all our clusters. Now here what we're going to do, we're going to download Python. So how can we do that? We're going to go sudo apt get install Python 3, and what we're going to do, we'll just copy that and we're going to do it on every one of these virtual boxes. We'll have to tick yes, thank you, and we should get the latest version of Python installed. I believe that will be 3.9. Once that's unpacked, then what you have to do is we're going to install pip. Now we need this to get numpy working. So let's go ahead, sudo apt get install, and we need python 3-pip. I'm going to copy that, enter, yes, and do that on all the other nodes. Once that is done, then we need to import, we need to check if numpy is there. So let's go sudo apt, now we need to go pip3 install numpy. And we're going to do that across all the boxes. And you can see that I've already downloaded that numpy version. So go ahead, do that. Now the thing that you'll find when you go into Python 3 is that numpy may return an error. If it returns an error, then the bit of code that you actually need to download is here on the screen. Sudo apt get install libatlas base dev. Now I'll put a link for that in the description. I had an issue there. So anyway, once you've imported numpy, you're all good to go. So we're going to create a bash file, two bash files. One is going to be called run, one is going to be called run all. Run is going to have the base Python file simulation that we're trying to run each time, and run all is where we're going to actually put the arguments for the simulation file. So here you can see we've called it simulations, but on our actual box we've called it simulation. So just not to confuse ourselves, I just change it there. Now run, the first thing you have to have is a hash there, and then an exclamation mark, /bin/bash. Now you need to have this at the top of every bash file on the cluster. Then we're going to do sbatch, and we're going to declare a few variables. We're going to declare the number of nodes, which is going to be 3. We're going to declare sbatch parameter the number of tasks per node, and this is going to be 4, and we're going to declare sbatch time, which is going to be the maximum time that something can run for. Now I'm going to say that that's going to be 10 minutes. Once I save that down, all I need to do is I'm going to use echo, which will just print to the screen the functions, and we're going to get our args back. Then we're going to just call Python 3, and we're going to call that Python simulation file, and we're going to include our arguments. So this is going to unpack our arguments into this simulation file. Now there's one very important bit in this run file. We actually need to include this SD-slurm submit directory. So whichever directory we actually submit to, that's where we want the output to come back to. Now we're going to move on to this run all file. So what's this run all file? Well, essentially this is where we're going to submit the different permutations. So we're going to have a number of parameters for our simulation file. So we're going to have our sims, our volatility, and our price. So we're going to have 4 sims in something, do something. Then we're going to have tab for volatility in a number of parameters, do something. Then we're going to have for price in a number of parameters, do something. What is that something? Well, I want to print back to the screen, so we're going to have echo sims dot volatility dot price. So this is just a bit of bash scripting for you guys. Now here is where we use sbatch, and we're going to have the export. Now what are we going to export? We're going to export the argument. So I need to export args that's actually equal to these list of strings here. Now I'm going to put spaces in there. Why do I need this? Because this is the arguments that's going to be picked up by run and placed within that file. So that is really important. Now, what do I want to do for an output? Well, for an output, I want files to be generated each time that we start one of these processes, and I want it to go to a results folder. Now, I don't have a results folder, so I'm just going to make one. mkdir, and I'm going to make results, if I can spell it correctly. Let's list that. Excellent, results. So a results folder, what do I want the title to be? Well, this sims volatility price seems pretty good. I'll make that out. Now, at the very end of this file, this line of sbatch, I need to name the batch script that I want to run, and it's going to be run. So for each one of these variable combinations, we're going to do run. Now, at the end of each do, all we need to do is go done, done, done. Awesome. So once we've done that, we just need to add these files to our cluster. So go back to our master node, nano run, save that down, nano run all. Go to our run all. Now, hopefully I don't need to explain to you guys why I've been editing in Visual Studio Code here. It's just much easier than typing away in the terminal here. So once we've done that, essentially we're good to go. Now, the way we actually submit this is just by running bash. We're just going to bash run all. Now, sorry, one thing I have forgotten to do is we're going to include the variables and parameters for which we have the sims, the volatility, and the price. So that's my mistake, no problem. Let's remove the run all, and we will name that now. Now for the simulations, let's make them fairly intensive. We'll go 10,000, 100,000, 1 million, and just so I don't go cross-eyed, 10 million. Now, what if we even do 100 million? Is that going to be too crazy? 3, 2, yeah, 100 million. Okay, good. Whew. Volatility will go 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Oh, volatility of 90% is going to be massive. And then for the prices, we can go 50, 150. Oh, let's go 25, 50, 75, 100, 125, 150. Now, the reason I'm doing this is because I'm just demonstrating variables. Obviously, this isn't a very practical application. I'm just simulating a whole bunch of different prices, different volatilities, different simulations, but we will go through a scenario risk analysis next time. So that is going to be very valuable. So we'll copy that, go over to our cluster. We will nano run all, that bash file, save it down, and essentially we're ready to go. So to execute that, we just go bash run all, enter, bang, and you can see it submitting all of those jobs there. Now that is incredible how many jobs have been submitted. To actually view the jobs now, we can go SQ, and we can see the jobs that are running across our clusters, right? And the jobs that are still to be run. And every time we execute this list, the list will get smaller and smaller and smaller. Now, because we put some 100 million simulations in there, it's going to take quite a while for those ones to run. So you can see that this list has got very small. Oh, bang, gone. Okay, that was a lot quicker than I thought it was going to take. That's fantastic. So now that has nearly run, what we're going to do is we're going to cd into the results, take a look at the list, and we'll open one of these files. Now you can see that it is not happy with our arguments. So what we have is an unsupported operand type from string to integer. So there's a very important thing that we need to actually do. So this error for int is really important. Essentially, when you use this argument, what we're doing is we're taking in the arguments as text. So we need to classify what they are. This is going to be an int for the sims, the same as price in this case, int. But this is a float for the volatility. So we'll save that down. We'll remove the file on the cluster, remove simulations, and we'll remake simulation, copy that down, save it, and rerun. Bash run all. Satisfying when you have all the infrastructure up in place. It's super easy to run again. It's even easier to SQ and take a look at all your files. Now, if you wanted to cancel one of these, it would be super simple. All you need to do is go cancel and then name the number. Now we'll just let that run. Now we should be able to start seeing in our results folder that there are files starting to appear. And if we open these, we can see that we have our stock paths that have been printed out. So potentially we actually need to print out not the array, but the individual paths and get it in some other file format. Now we can see the total time that it's taken to run. Now I hope you got a lot of value out of this tutorial. You learned how to use Slurm, you learned how to install Python and run Python scripts on the cluster. So next time we're going to be diving into how we can actually do parallel computing on the cluster, so stay tuned for next time. Until then, YouTube, see you later.